of pharmaceutical industry. I will explain briefly of it. Pharmaceutical is something that related to medicinal drug they use or sell. Means they use drug to make medicine. The importance of this industry, including these three, which is discovery new medicine, provide healthcare, and economic benefit. Move on, this is a chemical engineering problem in this industry. Mostly the chemical engineering will focus in research and development. They will hardly use mathematical and predictive approach to solve the pharmaceutical problem.
Now let us see the flowchart of pharmaceutical tablet manufacture. As you can see here, there are three different types of tablet manufacture, which are direct compression, dry granulation, and wet granulation. In direct compression, it will skip the milling process, where the product of this direct compression will directly go to blending process. As for dry granulation and wet granulation, from the dispensing process, the powder will go to milling process, then to this process. However, for wet granulation, it will undergo drying process. Then, in blending process, it will go to tableting process, then to coating process, lastly, filling and packaging process. Next, in drying operation, we can see some thermodynamic application. Drying of wet granule is one of adiabatic cooling process where hot air is brought into contact with wet granule, causing the air to cool and some of the liquid of granule to evaporate. Heat is transferred from the air to the granule, but no heat transfer occurs between the wet granule system and its surrounding.
Next, we will talk about the system and efficiency in pharmaceutical industry. First, we will look at the system used in pharmaceutical industry. The common system used is HVAC system, also known as the heating, ventilation, and air conditioning system. It is a device that controls the temperature of the surrounding by adjusting the temperature to the required setting. We can calculate its efficiency by using the following formula by knowing the inner and outer temperature of the two mediums. Next, we will talk about how to improve thermal efficiency in pharmaceutical industry. There are various methods and I shall list out a few. Firstly, you must make sure the motors are properly sized because too large motors will consume too much energy. Besides that, old motors should be replaced with new motors with high efficiency. Lastly, regular maintenance should be done to ensure that all the machines are working properly and all the energy input will produce sufficient energy output that is required.
3. Start.
Greetings again to Dr. Gidon. Now I would like to conclude the pharmaceutical industry. The economics literature on the pharmaceutical industry has made many valuable contributions in framing some of the important issues and providing useful, although rarely definitive empirical evidence. Nevertheless, we still lack complete answers to some of the basic questions raised by the policymakers and academics. If the moral hazard effects of insurance justify some forms of control, which forms provide the best trade-off between reasonable control of cost, access of patient, incentives for efficient mix of medical services, and incentives for innovative R&D? Is there any case for separate regulation for promotional activity for pharmaceuticals distinct that apply to other consumer products? If so, what forms of regulation of promotional activities yield the greatest net social benefits? And how does this differ between prescription and over-the-counter medications? These are only some of the interesting questions that remain to be explored. That's all from me for the conclusion. Thank you.
Is formed from the remains of animals and plants from millions of years ago. The many layers of mud that covered the oil turned it into crude oil. This crude oil are then sent to oil refineries to be processed to various hydrocarbons such as kerosene and gasoline. There are various chemical engineering problems in this field. One of the problems that exists is it is difficult to extract good quality of oil and gas. This is because of the various and inconsistent data that makes it difficult for the chemical engineers to determine what are the procedural for the oil field. Besides that, complex problems such as sanding, where the sand plugs the oil well, affects the production rate, and this causes problems to chemical engineers as well. Other than that, Abundant oil fuel will release methane gas to the environment, and it is a chemical engineer's job to address these environmental problems. They can do so by plugging the old oil well with cement.
Greetings to Dr. Gidon. Today I would like to present about the flowchart on the oil and gas extraction industry. There are four main levels in extracting this oil and gas industry. The first level is exploration. This involves the search of rock formation associated with oil or natural gas deposits and involves geophysical prospecting and or exploratory drilling. The next level is well development. This occurs after exploration has located an economically recoverable field and involves the construction of one or more wells from beginning called spudding to either abandonment if no hydrocarbons are found or to well completion if hydrocarbons are found in sufficient quantity. The next level is the production process. This is the process of extracting the hydrocarbons and separating the mixture of liquid, hydrocarbons, gas, water and solids, removing the constituents that are non-sealable and selling the liquid hydrocarbon and gas. Production sites often handle crude oil from more than one well. Oil is nearly always processed at the refinery. Natural gas may be processed to remove impurities either in the field or at a natural gas processing plant. The last level is the site abandonment. This involves plugging the wells and restoring the site when a recently drilled well lacks the potential to produce economic quantities of oil or gas, or when a production well is no longer economically viable. Now let's move on to the applications of thermodynamics in the oil and gas industry. Let us consider the example of a natural gas heating system in the oil and gas industry that provides warm air for heating a building. This example could also apply to a system that provides hot water for heat. Besides that, thermodynamic properties are also equally important in predicting pipeline operations accurately in oil and gas industry. This is all from...
The unit is used to recover a vapor that released to the atmosphere in oil and gas industry. The vapor must be recovered because it contains a hazardous chemical such as ammonia. To calculate the efficiency of recovery, this is the formula. M1 is mass flux through vapor line, M2 is mass flux through vent assist process, while M3 is mass flux through vapor incinerator. You substitute into this equation and you can get the efficiency of recovery.
Overall, we know that thermodynamics play a big role in most operational part of oil and gas industry. With thermodynamic application, refining of crude oil can be done, and this proportion can be used in our basic need, for example, in cosmetic and pharmaceutical. Therefore, it is important for us to know and understand more about thermodynamics and implement it in this industry.